Hey, today we are going to talk about solving one-step inequalities. So the good news is you already know how to do it. The only difference is that now instead of an equation with an equal sign, we're going to have an inequality, which is going to be that Pac-Man or that alligator mouth that we talked about the last few days. So those are our inequality symbols. And again, we're solving one step, meaning we just need to do one thing and the problem will be solved. So to solve inequalities for an unknown variable, remember a variable is like your x or your y or your t for Turner, you're going to use inverse operations. Okay? So we're using inverse operations. And remember, inverse operations are opposite operations that undo each other, right? We're just doing the opposite. So the opposite of adding, we've talked about, is subtracting. Okay, subtracting. The opposite of subtracting is adding. Okay. The opposite of multiplying is dividing. And remember, dividing can look lots of different ways. We could have just a basic division symbol, we could have a fraction, or we could have a cowboy and horse house, okay? But all of those are dividing, okay? And the opposite of dividing is multiplying. And again, remember, multiplying could be a big dot, could be the letter X, could be your parentheses, okay? Lots of ways that represent multiplying. So we've already used those a lot, so you should be pretty good at this already. We're going to go back over our symbols again one more time. So identifying symbols, which inequality symbol is represented by each graph. So today we're going to solve and graph, so we're going to need to use this information quite a bit. So again, yesterday on those notes we talked about when their circle is shaded in, when it's colored in like this, then we're going to have our equality line in our answer, okay? And then we're going to follow the arrow. So this arrow looks like this, so my symbol will match it. And that's what that graph looks like. So this one, same thing. My arrow looks like this, so my symbol will match it. And then on the bottom, you can see they're not shaded in. They are open circles, unshaded circles. So I'm not going to have that line, but I am going to follow that same arrow rule. So this arrow looks like that. So that's the way my Pac-Man will look. And then this arrow looks like that. And that's the way that Pac-Man will look. All right, so we're going to remember that and use that as we solve these example problems. So open it up. And we have a couple of examples to solve, and you guys are going to be professionals. So example number 1, x plus 15 is greater than 6. Okay, so our first job is still to split the problem. So I'm going to split the problem, and instead of down the equal sign, I'm going to do it down the inequality. And I'm just going to bring that inequality all the way down. Okay, and then I'm going to circle what I want to get rid of. Just like before, I'm trying to get x alone. I'm trying to get the variable alone. And so the opposite of adding 15 will be subtracting 15. So I am going to rewrite x and 6. Okay, and then the opposite of adding, to move that over, would be subtracting. Okay, and my symbol is going to stay exactly the same in the middle. So now I just have to solve this. Well, if I have $6, can I spend $15? And the answer is no. And because it's no, I'm going to need my positive negative table. So 6 was a positive, and 15 is going to be that negative. Okay, so I have 6 and 15. And so I can see that team negative is going to win. So whatever I get, my answer is going to be a negative. And then I'm just going to subtract. So I'm going to take that 15 minus 6 because they're on different teams, right? Different sides, different signs. and I borrow. 6 out of 15 leaves 9. And so my solution will be -9. And when you're solving an inequality, the whole thing is the solution. X greater than -9, this whole thing. Whereas before, when we were solving equations, you could have just said -9. But now we have to say the whole thing. X is greater than -9. So we're going to practice graphing. So I'm going to go to -9, and I'm going to put a open circle. And the reason it's open is because my inequality symbol does not have the line underneath. So it's not equal to, okay? And then I'm going to draw my symbol on top. So I'm going to say, okay, my symbol looks like this. And so remember, it makes an arrow. So it points to the right. So I would shade everything to the right. And again, it matches the arrow at the end of my number line. It matches the symbol in the problem. And that's how we graph and solve. So let's try another example. So example 2 says C minus 13.5 is less than or equal to 21. So I am going to draw my line. I'm going to split my problem and bring my symbol all the way down, staying exactly the same. And I'm going to circle what I want to get rid of. Okay, I want to get rid of subtracting 13.5. So I know the opposite is going to be adding. So I'm going to rewrite my problem and my number over here. And then I'm going to move my 13.5. So when I move it, the opposite was adding. And now I just have to solve this. So remember, anytime we have decimals, we're going to think of those decimals like money, okay? I don't have any negatives, so I don't need a negative strategy like I did up here. So I'm going to think of this like money. And remember, when we think of it like money, we're going to line up our decimals, like buttons on a shirt. So I have $21 and $13.50. So thinking of that like money, I'm adding, and now I have $34.50. And again, I can drop that 0 now that I'm done solving. So I just have 34.5. And again, these are all positives, so my answer will stay positive. So my answer was C. The symbol stays the same. And then again, we have 34.5. Okay, so I go to 34.5, which will be right in between $34 and $35 on my number line. Okay, and I'm going to put my dot in the center, and I look at my symbol and I say, oh, it has an equality line. So that means it's going to be equal. I can shade my dot in. Okay, so I shade my dot in, and then I draw my symbol on top. So my symbol pointed this way. See how they match? And that means if I turn that into an arrow, it shades to the left. And again, you can check by checking the end of your number line. Does that end of my number line match? Yes, it does. So again, we just shaded that way. All right. And that is solving number 2. Solving number 3, we have 3K is greater than or equal to -15. So I'm still going to split my problem. Okay. And I know that this dot is going to be colored in, just as a reminder, because it has the equality line. And I can't quite solve this yet because we need to write it out. So what invisibly is between 3 and K? That would be 3 times K. Okay. And I rewrote it, and now I can circle what I want to get rid of. So I want to get rid of my multiplying by 3. And so to do that, I would need to move it over. So I have K, same symbol, -15, and I'm going to divide by 3. Divide by 3. Okay? And so I have a negative and I'm dividing, so I need integer man. Always need an integer strategy when there's a negative integer involved. And then 15 divided by 3 is going to be 5. So 15 was negative, 3 was positive. So my answer is a negative. And again, my letter K just comes down. So again, the whole thing was my solution. The K, the symbol, and the -5. You have to have it all in your answer. Okay, so let's graph it. We're going to find -5 on our graph, which is here. I'm going to put a colored in shaded dot on -5 because my line underneath my symbol tells me that it's equal to. And then I'm going to draw my symbol on top. Okay, which you can see matches the original, matches the answer. And if I draw that in an arrow, it points to the right. And again, I can check with the right side of my number line. Okay, does it all match? Yes, it does. Example number 4, we have f divided by 20 is less than 6. So before I solve, I'm going to write it out as division instead of a fraction. So I have 4 divided by 20 is greater than 6. And I'm going to drop my symbol down. Okay, I know I'm going to keep f. All right, we're trying to get rid of our divided by 20. So we know the opposite will be the multiplying by 20. So I have 6 times 20. And 6 times 20 is 120. So I have F. My symbol stays the same. And then the 120. Okay. And so I go to 120. And I'm going to have an open circle because I do not have the equality line underneath. So I just make an open circle on 120. I put my symbol on top and make that arrow. It's pointing to the left. So I shade everything to the left. And I just check with the end of my number line. Does it match? Yes, it does. And that's example 4. All right, and then this is an example of a kind of star-like question you might see. It says, which number line represents the solution to x divided by 1.5 is less than 2? Well, you'll notice that all the solutions are 3. So we don't actually need to solve this, but if you did, remember the opposite of dividing is multiplying. So we just multiply these two, and that's what gets you your 3. But again, they already told us it was 3. What we're going to focus on is our sign. So you can see that our sign here looks like that. Our circle that goes with that symbol, remember, is an open graph, which means that letter B is colored in and therefore cannot be right because it is shaded. And remember, shaded has a line underneath, okay? So we know it can't be B. And then the direction is shaded different on letters A and C. So open circle, both match, but this one is shaded to the left and this one is shaded to the right. So we have to decide what direction does this point? Well, let's put our symbol on top of our dot and see. So same symbol, right, every time. And we can see, oh, it matches this arrow. Okay, this one is pointing the wrong direction. Okay, so this one is wrong shading because this one is shaded to the left, right, and this one's shaded to the left. Okay, and again, you could match the symbol with the end of that arrow or even the end of this arrow. They all match, whereas this one matches over here, but we can see clearly that it does not match this way. And that's how we solve if we know our inequality symbols.